So let's talk about a problem that is hiding in plain sight. We are creating this incredible, massive ocean of digital stuff every single day. But have you ever stopped to wonder, will any of it actually be around in 100 years? I mean, really think about it. Every photo you take, every important document, all of our scientific and cultural heritage, it's all just a fragile stream of ones and zeros. We treat it like it's permanent, but is it? Are we building a lasting digital legacy, or are we just creating a digital ghost town that's going to fade away? Well, according to the people who study this, we're up against three major threats. First up, technological obsolescence. You know, the simple fact that the hardware and software we use today will be ancient history tomorrow. Then there's physical degradation. People call it bit rot, where the hard drives and tapes literally just fall apart over time. And of course, there's plain old data loss and corruption. It's a triple whammy aimed right at our collective memory. Okay, so you're probably thinking, hold on, we have the cloud for this, right? And yeah, you're not wrong. The cloud is an absolutely incredible tool. It's built for lightning-fast access and unbelievable flexibility. It has totally changed the way we work and live, no question. But here's the thing, and I love this analogy. Using the cloud for permanent, long-term preservation is a bit like this. You don't plow a field with a Ferrari. A Ferrari is a masterpiece of engineering, built for one thing: speed. But it is definitely not the right tool for every single job. For that kind of heavy-duty, long-haul work, you need a completely different beast. You need a modern, powerful tractor, something built specifically for endurance and heavy lifting. It all comes down to using the right tool for the job. And that begs the question, is the Ferrari of the digital world the right tool for preservation? You know, what's interesting is that even the cloud providers know this. Take Google Cloud. They don't just have one type of storage. They have tiers. You've got standard for your hot data, the stuff you need right this second. But then, as you need that data less and less, it gets colder, and they move it to cheaper, slower options like nearline, coldline, or their deep archive storage. The cloud itself is telling us that not all data needs to go at Ferrari speeds. And that gets us right to the heart of the problem. The cloud's superpower is its ability to change and adapt on the fly. But archives? They're the exact opposite. They are built for stability, for permanence. We're trying to solve a permanence problem with a tool that was designed for constant change. So what do the real experts say? You know, the archivists who have been keeping history safe for centuries. Well, they have a pretty simple and powerful rule of thumb. The only archival methods that have truly, genuinely lasted are the ones where you can see the data with your own eyes. Think about it. Stone tablets, old books, film negatives. If you can see it, you can probably figure out how to read it, even centuries from now. This is exactly where a technology called DOTS comes into the picture. It's built on that exact principle. Now, DOTS is a really unique medium. You can save all the same stuff you'd save to a hard drive or an SSD, your applications, your documents, your images, but, and this is the key, it saves the data visually onto a super stable, chemically inert tape. It literally translates our digital world into a physical format that you can see. And this is what that looks like. It's not some invisible magnetic charge that could get wiped. Nope. It takes any digital file, I'm talking a document, an application, a video you'd save to an SSD, and it writes it visually onto a special metal alloy tape. Now, a laser doesn't burn or etch the data. Instead, it creates a microscopic, permanent phase change in the metal itself. Now, this whole approach builds on an idea we already know works. Analog film is a perfect example. It's so elegant because it's visual. All you need is light and a lens to see it. The problem, of course, is that its data density is just way too low for our modern world. Today's digital media, it's the complete opposite. Massive density, but it's all trapped inside these complex machines that have a very, very short shelf life. So what makes this a forever technology is its incredible resilience. Carnegie Mellon tests have confirmed a lifespan of at least 200 years. It's immune to EMPs, it can't be hacked, it uses zero power in storage, and, this is huge, because it's a write-once, read-many medium, the original record can never, ever be altered. Now, that last point, the fact that the record is unalterable, has never been more critical than it is right now. In the age of AI, we're facing this new and frankly terrifying threat, the loss of data provenance. An AI could maliciously or even just accidentally rewrite our history, and we'd have no way of knowing what was real and what was fake. This is where the physical, tangible nature of DOTS becomes such a powerful defense. It's what's called a worm medium, which stands for write once, read many. Once the data is written, it is physically impossible to alter it. This guarantees that an archived file is the true, untampered original, completely safe from any AI manipulation or any other kind of cyber attack. And because DOTS is visual, it can do this really unique, future-proof trick for our most precious files, our images, videos, and sound files. It's called bit plane image preservation. So here's the deal. It takes a media file and breaks it down into its most basic raw data, the bit planes. Then it just records that raw visual data. What does that mean for you? It means that 100 years from now, you won't care if JPEGs or MP3s still exist. All you'll need is a basic scanner to perfectly reconstruct the file from scratch. It's truly timeless. The DOTS technology is rock solid. In fact, a proof of concept was successfully demonstrated for the U.S. Central Intelligence Agency. I mean, if it's good enough to validate for preserving their most critical information, you know it's the real deal. Having a secure vault is only half the battle. You still have to find what's inside. For these massive new archives, the solution comes from a partnership with Iron Mountain and its Smart Vault platform. And this is just a perfect pairing. DOTS acts as the impregnable permanent vault for the original master files. Then Iron Mountain's Smart Vault, which is powered by Google Cloud's incredible AI, serves as the active intelligent catalog. It lets you use AI to search, preview, and manage your archive without ever having to touch the deep freeze original. Okay, so this all sounds great, but it brings up the practical question, right? What's the real cost of storing something forever? We can't just look at the price per gigabyte today. We have to think about the total cost of ownership, or TCO, over decades, even centuries. And this is how DOTS completely changes the math. First off, the media lasts for over 200 years. That means you get to eliminate that incredibly expensive, risky cycle of migrating all your data to new systems every few years. It doesn't need giant power-sucking air conditioning systems to stay cool, and you don't have to constantly run checks to make sure the bits haven't flipped. All of that adds up to massive long-term savings. The economic advantage of this technology isn't just for massive corporations. Get this, for any archive larger than just 20 or 30 terabytes, DOTS actually becomes the more cost-effective solution over the long term when you compare it to the cloud. In fact, depending on the AWS Glacier Deep Archive Zone, DOTS becomes less expensive in less than 6 years and no more than 10 years. And that petabyte scale, it's getting here way faster than we thought. And the reason is generative AI. Companies like Iron Mountain are seeing a huge shift. Before, the idea of digitizing an entire historical collection was just too daunting. But now, with Gen AI tools that can make those collections instantly searchable and valuable, organizations are racing to digitize everything. But this doesn't have to be an either-or battle. The future is almost certainly a hybrid one. You can imagine a system like Iron Mountain's Smart Vault running on the cloud, acting as the smart catalog. That's your Ferrari for fast, searchable access. And then, in the background, you have your DOTS media serving as the permanent, unchangeable library. That's your powerful tractor, ensuring the collection survives forever. It's truly the best of both worlds. So we'll leave you with this final thought. We are creating more data, more art, more science, more history than any generation to ever walk the earth. We have these amazing tools to analyze it and learn from it. But if we don't solve this preservation problem, is it possible all that knowledge just vanishes? Could we actually be the first generation in all of human history to lose its own legacy? It's a big question to think about. We've really only just scratched the surface of this incredible technology. So if you're as fascinated by all this as I am and you want to learn more, we've got you covered. For a real deep dive into this discussion, we've provided a link in the comments below. It's a fascinating lesson, and I highly, highly recommend it. Thanks so much for joining me for this explainer.